Today I'm going to be cooking sirloin steak, and if we look over here, these are the ingredients. What I'll be using is Lowry seasoned salt, some garlic powder with parsley, and some Montreal steak seasoning. And here we have the steak. It's a little brown due to oxidation because it was in the fridge for a little bit. And then to add some more flavor, we're gonna add some butter. So there's a lot of ways to season your steak. I kind of like my steak with some garlic and a little more salt. So we're gonna be a little generous with the salt, a little generous with the garlic powder, and then we're gonna put on the Montreal steak seasoning. Then we're gonna flip it over. And while we're cooking, most of the seasoning is probably gonna fall off, so that's why I'm being a little generous here. Gonna flip it over, do the same to the other side. So the seasoned steak is looking pretty good. Looks like we got most of it covered. Right now it doesn't look as appetizing due to the oxidation color change, but we're gonna change that once we put it on the stove, so let's get to it. I put some butter on the pan, and now I'm gonna put the steak on the pan to cook. And the Maillard reaction was named after a French physicist / chemist, Louis Camille Maillard. The Maillard reaction causes flavor in many foods, such as the crunchy texture in toast, the charred taste in meat, and the bitterness of coffee. It also is responsible for a lot of aromas, such as the sweet smell of bacon. So it's a really cool reaction. It occurs in foods that are cooked at a high temperature, and this chemical reaction that's occurring commences between amino acids and reduced sugars. This produces different flavors and browning color depending on the food item that's being cooked. This reaction involves the sugars and amino acids in foods. Some types of sugars included would be glucose or fructose, and amino acids can vary depending on the type of food. So you might have valine for dairy, lysine for meat, and glycine for nuts. The recommended temperature for this reaction is going to be around 230 to 340 degrees Fahrenheit. At this temperature, the chemical reactions are occurring faster, and the heat evaporates excess water. And this is important for the reaction to be really effective and cause a nice browning of the meat. Too high temperature can cause burning, which is associated with charred, bitter flavors. So for this, I set the stove to around 3.5. That's a good temperature for my stove. For other people, it might be a little different, but what I'm gonna do is I'm gonna cook each side for 7 minutes, and then I'm gonna do some increased heating, maybe change the temperature to the 6 setting on the stove, so I could get some nice crisp charring on it, as that is a preference of mine for when I cook steak. The Maillard reaction occurs in 3 stages. In the first stage of the Maillard reaction, this involves a sugar amine condensation reaction to form an N-substitute glycosylamine. The nitrogen lone pair from the amine group attacks the electrophilic carbon on the aldehyde carbonyl, and electrons are pushed from the double bond onto the oxygen atom, resulting in a negative charge. Then a proton is transferred from the positively charged nitrogen to the negatively charged oxygen atom, and the lone pair of the oxygen atom attacks a hydrogen-forming OH2 plus group, which is a very good leaving group. Next, the nitrogen donates its lone pair to form an imine in the N-substituted glycosylamine, and water is kicked out. The amine is then deprotonated. In the second step of the Maillard reaction, an Amadori rearrangement occurs. In this rearrangement, an imine and amine tautomerism occurs, and a 1,2-N-aminol is formed. Next, a ketyl-enol tautomerism occurs, and the Amadori compound is formed. The electrons from the hydroxyl group oxygen are donated to form a carbonyl, and the alkene enol attacks a proton. Then the carbonyl is deprotonated to form a ketone, and the Amadori compound is generated. In the final step of the Maillard reaction, there's a variety of products that can be formed from the Amadori compound. This is why the amidoroid compound is very crucial in this reaction. Some of the products that are formed include hydroxymethylfurfuryl and pyruvaldehyde. These products can further react to form other types of products. Melanoidins, a class of brown polymers, are an example of an end product that produce the cooked color in food. Okay, so 7 minutes have been up and I'm gonna flip the steak. I put some more butter on it for flavor. And we'll get back once another 7 minutes have passed and we'll see how we're doing. Feeling a little daring today, I put some more butter on and 7 minutes have passed, so I'm going to increase the heat and do 2 minutes on each side to get some crispy texture on the outer layer of the steak. Okay, so now I'm going to flip it over for another 2 minutes on the other side. It's looking like it has some crisp to it, so that's looking pretty good. Okay, enough time has passed for us to be done with this. It looks like there might be some burning, but I think that's just the seasoning, so I will check in after I've peeled off this burnt seasoning. All right, so we made the steak. Looks like it came out pretty decent. There you go. It's good, bro.